So now that you've seen the definition for length of a vector, I want to apply it in R2. So just the length that we're used to in the xy plane. Now, keep in mind that the definition you've seen now for the norm of a vector extends to a vector in Rn, where n is any positive integer. So we could find the length of a vector in R16, with using that definition, which is not something that we can, think of physically, or not easily. I don't know. You could find a way to do it, maybe. But anyway, I want to work an example that's just in the xy plane, so we can tie it back to the length that you're used to. So the vector 3, 1 here, I can represent that as a line segment or a ray going from the origin to the point 3, 1. So 3, 1. So, this isn't going to be perfect, but there's the point 3, 1. So I could represent this vector v like that. And we want to find the length of that vector here. So if you're using the distance formula in R2, the coordinates here are 3, 1. The coordinates here are 0, 0. So the length of this line segment from the distance formula, or let's go even further back. If you forgot the distance formula, we could use Pythagorean theorem here. I could form a right triangle where this side of the triangle has length 3. This is the x-coordinate. This side of the triangle has length 1. And so the length of the hypotenuse here would be 3 squared plus 1 squared equals the length of our vector, equals the length of our vector here squared. Notice that what I've ended up doing is first component squared plus second component squared, just like the formula tells us. And so this is 9 plus 1, so 10 equals the norm of v squared. And so the square root of 10 equals the norm of v. Okay. But it does amount to just distance formula. If you guys remember, the general distance formula is square root of x2 minus x1 squared plus change in y2 minus y1, sorry about the background noise again, squared. And if we're representing our vector as a line extending from the origin, so the x1 and the y1 are both 0, then you have just the x squared plus y squared, take the square root, and that's the formula that you see in the notes.